student, I am Zafar Ahmad. Welcome to Z classes. Today we will learn physics class 9, chapter 1st, part 1, matter in our surrounding. Topic to be covered: introduction, matter, non-matter, constitution of the matter, mass, volume and weight, difference between mass and weight, difference between matter and non-matter, physical nature of the matter, evidence of particles in matter, characteristic of particles of matter, properties of matter, particle theory of the matter, properties of substance and objects, example of physical properties, classification of matter, physical and chemical properties, difference between physical and chemical properties, intensive and extensive physical properties, difference between intensive and extensive physical properties, type of state or physical matter, solid state and their properties, liquid state and their properties, gas state and their properties, plasma state and their properties, post-Einstein condensation state, explanation of molecular structure of solid, explanation of molecular structure of liquid, explanation of molecular structure of gas, change of state of matter by changing the temperature, by changing the pressure, interconversion of state of matter, solid to liquid, liquid to gas, gas to liquid, liquid to solid, solid to gas,
gas to solid, composition of matter, factor of affecting evaporation, factor affecting the rate of evaporation. Evaporation causes the cooling effects of changing in temperature, latent heat, effect of change of pressure, latent heat of vaporization, latent heat of fusion, evaporation and boiling, difference between fusion and vaporization, conversion of solid, directing into the gases, sublimation, sublime and sublimate, atmospheric pressure, compressibility, condensation, temperature, rigid and fluid, kinetic energy, liquefaction of gases, dry ice, density, diffusion, evaporation, fluidity, melting point, boiling point, freezing point, length, Brownian motion of particles, absolute temperature of scale, hardness, specific heat, viscosity, color, order, size, shape, solubility, buoyancy, concentration, fusion, dissolving a solid in liquid, rigidity, factor on which the evaporation depends, humidity, wind speed, surface area, absolute temperature scale, Kelvin scale, Celsius scale, relation between Kelvin and Celsius, type of matter on the basis of chemical properties, mixture, homogeneous mixture and heterogeneous mixture, pure substance, element, compounds, molecule, atom, theory of molecular structure of the matter, material and their types, homogeneous material, heterogeneous material, explain of chemical properties, substances, metal, non-metal, malleability, ductility, conductivity, luster, extra. All of these topic we covered. First of all, introduction of matter. Everything in our surrounding has a large variety of things with a different shape, size, colors, and texture. In this universe is made up of material which scientists have named matter. We also see, as we look around, a pencil, a pen, table, air, the food we eat, the cloth, the water we drink, the wall of our house, etc. Everything made up of matter. All of these things occupies some space, have a mass and volume. Hence, they are called matter. All of these matter. What is the matter? Anything which occupies a space and has mass is called matter. Occupies means volume. Anything which has volume and has mass is called matter. Example: pen, air, book, water, and milk, etc. All of these are matter. Matter has energy. Matter is everything around us. Matter is everything you can touch, see, feel, or smell. Pen, air, book, water, milk, air are all of these matter. What is non-matter? Non-matter substances which has neither mass nor volume and thus having no space, or we can say that doesn't have any appearance but existence. As said earlier, it actually doesn't contain anything at all. Example: feeling like anger, happiness, etc. Cold. Non-matters. Example of non-matter: friendship, love, idea, taste, a smell, manner, honesty. All of these are non-matter. They have no occupies space. What's a constitute of matter? Every matter is made of tiny particles. These particles are atoms or molecule. Atoms are the smallest building block of all matter. They are extremely small. Matter can be described its physical properties or chemical properties. What is mass? Mass is how much matter is in an object or body. We measure mass in gram, kg, milligram, etc. All of these here are mass. Earth is also mass. What is volume? Volume. Volume is how much space it takes up. We measure volumes in liter, milliliter, etc. Here are the example of volume. What is weight? Weight is the measurement of the pull of gravity on object. The more matter the object has, however, the more gravity will pull on it. Your weight can change based on where you are. Moon has different than the earth. Weight change the space. Weight is change. Weight is often measured in pounds. The SI unit of weight, Newton or kg meter per second square. Difference between mass and weight. Here is the mass and other column is weight. Mass of a body is the amount of matter contained by the body. Weight is the measurement, the pull of gravity on an object or body. It is remain constant at the different places. It is different at different place. It is a scalar quantities. It is a vector quantity. It is measured by physical balance. It is measured by spring balance. Its SI unit in kg, it means kilogram. Its SI unit is Newton. Here are the difference between mass and weight. And next, difference between matter and non-matter. Here is matter and another column is non-matter. Matter has mass and volume, but non-matter has neither mass nor volume. Matter occupies space. Non-matter doesn't occupy space. Matter mates with particles. Example: happy man, perfume. Non-matter doesn't mate with particle. Example: happy, smell of particles. And next, physical nature of matter. Matter is made up of particles. Everything around us is made up of tiny pieces of particles. These particles of matter are constantly moving. They are in motion. Particles which makes up matter are atoms and molecules. And next, evidence of particles in matter. The evidence for the existence of particles in matter and their the motion comes from the experiments on diffusion and Brownian motion. All the matter take space and it has volume. Living thing and non-living thing is made from matter. All of this evidence of particles of matter. Characteristic of particles of matter are: particles of the matter have a space between them. Particles of matter are moving all the time. Particles of matter attack attract each other. Particles of matter are very small. Properties of the matter are: everything is made of matter. Matter is anything that has mass and volume. Properties of the matter describe matter. Example: might be its color, hardness, shape, etc. All matter can change properties. For example, water can go from ice to liquid form and then to stream or water vapor. Water properties can you think of describe matter. Particle of theory of matters. Matter is made up of tiny particles, atoms and molecules that are in constant motion and held together by the strong electric forces. Temperature affect the speed of particles. The higher the temperature, the faster speed of the particles. There are large empty space between the particle. Each substance has unique particles that are different from the particles of other substances. Properties of substances and objects. Here are the objects and other column are substances. Objects: sharp, small, mass, volume, beautiful, curved. Substances conduct electricity. Color, boiling point, freezing point, density, molality, etc. The properties of substances and objects. Example of physical properties: any property you can see, smell, touch, hear, or otherwise detected and measure without performing a chemical reaction is physical properties. Example of physical properties: color, shape, volume, odor, mass, density, texture, size, weight, length, conductivity, solubility, temperature, pressure, viscosity, state of matter, boiling point, melting point, freezing point, a specific heat. All of these are example of physical properties. Classification of the matter. Ancient Greek philosophers: matter is made up of four elements, is that air, water, earth, and fire. Earlier Indian philosophers: every living and non-living thing is made up of five basic elements called the Panchtattva: air, water, earth, sky, and fire. Therefore, the matter is composition of five constituents. Modern scientists: matter is classified on the basis of physical and chemical properties. Every substance has unique or characteristic properties. These properties can be classified into two categories. Matter are classified. Are these properties determined without changing identity of the substances. There are two types of matters: physical properties or physical nature. It is yes. Chemical properties or chemical nature. No. Physical properties also two types: intensive properties or extensive properties. Doesn't the properties depend on the amount of the substances? Color, texture, boiling point, melting point, and density are the intensive properties. Extensive properties: mass, volume, length, shape. How does the substances react the properties? Air, water, base, and other chemical. It is also the chemical properties. Physical properties are the characteristic of the matter that can be changed without changing its composition. Characteristic that are the directly observable. Example: color, density, boiling point, melting point, solubility, conductivity, ductility. Chemical properties are the characteristic that determine how the composition of matter change as a result of contact with other of the influence of energy. Characteristic that describe that behavior of matter. Example of chemical properties: magnesium bonds into oxygen to produce magnesium oxide. Combustibility, biodegradability, reactivity, etc. The example of chemical properties. Difference between physical properties and chemical properties. Physical properties and other column is chemical properties. Physical properties are properties that can be measured without changing the chemical composition of the matter. Chemical properties are the properties that can be measured by the changing the chemical composition of substances, can be measured without changing the identity of the substances, can be measured by the changing the identity of a substances, do not have a direct relationship to the chemical bond of a substance, do have a directly relationship to the chemical bond of a substances, may or may not be depend on the amount of the substances, do not depend on the amount of the substances. Example: mass, density, color, viscosity, volume, order, etc. Example: toxicity, oxidizing, radioactivity, combustibility, reactivity, flammability, etc. are the chemical example of chemical properties. Intensive physical properties. Intensive physical properties do not depend on the amount of the matter that is present. Example: color, taste, melting point, boiling point, etc. Extensive physical properties. Extensive physical properties depend on the amount of the matter that is present. Example of extensive properties: mass, volume, length, shape, energy, etc. Difference between intensive and extensive physical properties. Extensive properties and other column is the extensive properties. Independent properties and dependent properties. Size doesn't changes. Size changes. It cannot be computed. It can be computed. Can be easily identified. Can't be easily identified. Example: melting point, freezing point, conductivity, boiling point, pressure, order, density, taste, etc. Example of intensity properties. Example of surface area, amount of substances, small, length, mass, weight, volume, heat, energy, shape, etc. is the example of extensive properties. On the basis of physical properties, matter is classified or type of matters according to that state: solids, liquid, gases, plasma, and Bose-Einstein condensate. Matters. Definition of the matter: has mass or take a space. Anything is called matter. Matter are classified according to the state. Five type of matters: liquid, solid, gases, plasma, as well as Bose-Einstein condensate state. Liquid has shape, indefinite shape and definite volume. Solid, definite shape, indefinite volume. Gases, both are indefinite shape and volume. Plasma, indefinite shape and indefinite volume. Bose-Einstein condensate state, indefinite shape and indefinite volumes. Next, what is the solids? Matters which have fixed volumes and shape are called solids. Example: stone, wood, brick, iron, sugar, salt, coal, ice, etc. are the matters. All metal are solids except mercury and gallium. Rock and apple is also solid. Atom of solids is closely packed. It is very close to each other. Properties of the solid: solid have fixed volumes, solid have fixed shape, solid have high density, solids are heavy, solids does not flow, they aren't compressible, density does not changes, they don't need to container to hold them. What is liquid? Matters which have fixed volume but indefinite shape are called liquid. Example: milk, water, petrol, kerosene, alcohol, oil, etc. is the liquid. Since liquid can flow, it is also called fluid because all the example of given below is flow, water. There is also liquid, milk, water, juice. Atom of liquid is closer, looser than the solid. Properties of the liquid: they have fixed volume but not fixed shape. They have negligible combustibility. Liquid gets the shape of container. Liquid has less density compared to solid. Liquid is lighter than the solid. They can easily diffuse. Liquid has less intermolecular force compared to the solids. What is gas? Matters which have indefinite shape and volume called gases. Example: air, oxygen, hydrogen, nitrogen, carbon dioxide, etc. Example of gases. Since gas can flow, it is also called liquid. Atom of gas of molecules vary far from solid and liquid. Its molecule is very loose and very far from solid and liquids, and their intermolecular force is very weak than solid and liquid. Properties of gases: they have neither fixed shape nor volume. Gas gets the shape and volume container. They fills the container completely. Gas has very low density. They flow easily and fast moving than the liquid. Because of low density, gas are light. Gas has weak intermolecular force than the solid and liquid. The particle of gas have greatest kinetic energy. What is plasma? Matter which has neither fixed shape nor volume but ionized gas and free electron conductivity is called plasma. Plasma is fourth state of the matter. It's very good conductor of electricity and it's affected by magnetic field. Almost 90% of the universe is made of plasma. Highly energetic state of the matter. The sun matter is in the plasma state. Example: lighting aurora borealis, northern lights, the sun, the star, Lorentz tube, welding arc plasma, bulbs. When the electricity is a pass through the then the gas get inside the ionized and form the plasma glowing. A star glow due to the presence of plasma state of the matter. Plasma state is exit normally at the 10,000 to 15,000 Celsius. Sun star. Properties of the plasma: they have neither fixed shape nor volume. Gases gets the shape and volume container. They fill the container completely. Gas has very low density.
They flow easily and fast moving than the liquids. Because of low density gas or the light, gas has weak intermolecular force than the solid and liquids. Plasma particles are super energetic and super excited. Plasma is very good conductor of electricity. Plasma is the common state of the matter, Bose-Einstein condenser, also known as BEC. A Bose-Einstein condenser is a state of the matter, also called the fifth state of the matter, which is the typically when a gas of the bosons at the low densities cooled to the temperature very close to the absolute zero is called the Bose-Einstein condenser state. Example: neutron star, superconductor, and the superfluids. This state was the first predicted by the journal in 1924-25 Indian physicist Satyendranath Bose and the Albert Einstein, who was the based on the quantum formation of the physics but didn't have the necessary equipment to do. Bose-Einstein has been obtained by the cooling the vapor of the rubidium at 2787, the super and low temperature are the kernel and the kernel when the on June 5, 1995, after the sometimes was Cattrall also obtained the positive formation sodium rubidium at the MIT USA kernel Verman and the Cattrall got the Nobel Prize in the Physics for achievement in 2001. At this temperature, molecules motion ceases. At this temperature, the atom no longer the remain separated. This start clumping and the overlapping and called the superatoms. Superfluid liquid helium is cooled about the absolute of zero is the example of Bose-Einstein. Superfluid and superfluid, also known as the example of BEC. In a gas, each atom has its own energy and it is able to move. As we know, when these atoms are bosons, they are allowed to have the same energy at the same time. When the gas is cooled down, the atoms slow down and their energies decrease because of their quantum nature. The atoms behave as wave that increasing in size at the temperature decreasing. Then at this very low temperature, all of the bosons are able to be at the very same energy in the same quantum state. Properties of Bose-Einstein condensate state: superfluidity, that is, condensate can flow like liquid with zero friction through any wall or metal. Superconductivity, that is, electrons of the condensate can move through a material with zero electrical resistance. They could do not pass through the ceramic. Condensate state is a too cool that is a can freezing even a large building in an instant of the touch. It can be slowed down by the iron filling. They can be slowed down light. A Bose-Einstein is formed by the cooling a gas of the extremely low density about the 100,000 density of the normal air to ultra low temperature. More watch, see watch part 2, like, share and subscribe and bell the icon up. Thank you for watching our channel.